All right. Hello, everybody. Welcome back. I wanted to come up with a brief tutorial on sort of Linux fundamentals. Um, there's a request for it on Piazza, and also sort of based on my observation of some of the Piazza questions, it seems like it might just be worth kind of going through a little tutorial on how things work in Linux. So I'm going to do that here. Let me share my screen. Cool. Let me close that. Let me just open up a new terminal afresh. So what I wanted to do was, I wanted to touch on some Linux fundamentals and sort of why things work the way they do, a couple of conventions, and I wanted to frame this by doing a couple of different tasks. And so what we're going to do is we're going to write some scripts to parse some string data using like Bash and maybe some Python or something. And we will we'll see some script writing, and in particular I want to show you how to sort of programmatically download YouTube videos. I think that that's an interesting task to try to do, and one that's within your power in Linux. The second thing is we're going to see how to download and build a project from source. You've kind of already done this with libpng for homework 1, but it's still I want to use that as a way to go through like conventions and what people do when building software. And finally, I want to show you about like SSH, so the secure shell, basically a way of connecting to other computers so that you can like run programs on them. So if you have like a big server available, you might use SSH to connect to that server to run things that wouldn't fit on your own computer. And while we're doing that, I want to touch on just a couple of general things. So we'll go through things like, well, what is the terminal? What is the shell? What's the difference between those things? What can I do with the shell? And we'll touch on environment variables, things like bash scripts, a little bit on like redirection and piping and the Unix philosophy. And then once we get to building Elinks, this sort of reasonable software package, we'll talk about build systems and sort of the conventions there. And then again at the end, we'll talk about SSH and what would you do with like a remote computing resource available. All right, so first thing that I want to say then is, I'm a big believer in staying on the terminal whenever possible. I try not to use like graphical interface components, just because I think that when you touch the mouse, you end up being less productive. So like to the extent possible, I try to keep development and a lot of things inside of the terminal. I find it simplifies my life. And then there's exceptions if I need to like Google something or use a browser for something. But by and large, development can be done in the terminal. And so if you haven't seen Linux much before, which is possible, Linux is just another operating system like Mac or Windows. I think the majority of students these days have Macs, although some students still may use Windows. In my experience, both of them are kind of gravitating towards the Linux flavor anyway, especially when it comes to development. And so, on Mac, there's definitely the terminal, and really, Mac OS X, going way back, they, built the entire system around Unix, which Linux is also based on Unix. So they have a lot in common. And then Windows, with Windows 10, they have the Windows subsystem for Linux. You can actually run Bash and Ubuntu like as a native Windows program without any issue. So all of them have the same kind of, or a similar kind of setup, where you have available to you the notion of a terminal. And so, what is a terminal? If you haven't really thought too much about it, it just seems to be this dark window where you can just type in commands and have it do cool things for you, no problem. But if you've ever wondered, well, why do we have this text-based interface? Why is it that I type in commands and then in the same space I have the output show and it sort of scrolls up over time? And it turns out that's actually a historical artifact. So going way back, in time to the early days of computers when we didn't have monitors available. We instead had typewriters. And when we didn't have monitors, what would happen is, I guess this is a good example. Um, the so when we didn't have monitors available, and so instead we had these typewriters. And so on a typewriter, you'd hit a character, you'd type a key at a time, and then it would actually mechanically put ink onto physical paper, and you would see what you were typing on the paper. And every time you hit enter or executed a command, the paper would sort of scroll up over time, and you could see your command history that way. And then off to the side, each of the keys was also electrically connected to a computer through basically the historical equivalent of a USB port. And so all of the keys were hooked up that way. So you would type in stuff. All of the things that you type would be printed onto the screen. And then when you hit enter, like all of the signals would go off to the computer. It would run the command, and then all of the output that the program would print out got sent back to this teletype machine, which would then print out the output again physically on this paper. And you would just sort of see this paper would scroll up over time, and you'd see the command history. So it's really just a historical artifact. The way that the terminal works is it's essentially emulating that teletype or TTY type of system, and in fact, like there's definitely I know that there's like do-it-yourself projects where you could like buy an old like 1970s teletype machine and hook it up to your modern Ubuntu 20 and actually still have it work just fine. Yeah, so the terminal application itself, what it's doing is it's emulating a teletype system, and that like piece of history is still with us in modern releases of Ubuntu, where they use the abbreviation TTY to refer to an emulated teletype system. So when I use the W program, it's telling me who's logged in through what. It's telling me I, K Leach, am logged into emulated teletype terminal number 1. And then and that's kind of the like the interface or the way that I type things into the computer. Within the terminal window, however, there's also like, well, what is the program like using to display within the terminal? And that's called the shell. So the shell is the thing that displays like that I enter commands in, and it's what displays this prefix here, this username and computer name, and then the current directory that I'm in. That's from the shell. And so the shell and the terminal are technically different, although they're pretty closely intertwined. The terminal is only there to deal with keystrokes and printing things out, but the shell is there to interpret commands and interface with the operating system for you. So whenever I type in a program or a command like ls, list all of the files in my current directory, the shell is taking that command and it's giving it to the operating system. The operating system allocates memory for it, actually executes the instructions inside of the ls program, and then it takes all of the stuff that ls printed out and it gives it back to the shell, and then the shell displays it here for me, right? And so the shell, right, is a layer or a shell that sits on top of the operating system that lets you access the computer's resources. And there's a bunch of different flavors of shell. Most of you are familiar with or are using by default. The born again shell, BASH, born again. That's the common one that's sort of deployed with most, well, at least with Ubuntu anyway. There are a variety of other ones. So there's things like Dash, which is a really fast shell. Dash is has reduced features, so there's no colors, for example. There's also, let's see, CSH, TCSH, ZSH, and Fish is one that I like. All of them have a variety of different features, things like tab completion or built-in functions to help you find files or whatever. But they all basically do the same thing. They're there to take in commands that you give it and then execute or use the operating system on your behalf. Okay. Now you might be wondering then, well, whenever I give a command to the shell and it executes for me, well, basically I'm just giving it program names to execute. And that sounds fine, but like how does it do that, or like why? Like if I type in ls, how does it know where to find ls? Where is the ls program actually on my computer? And so what the shell is doing behind the scenes is it's looking through special directories to sort of find the location of programs that you care about. And you can actually see the default directories that your shell searches through is stored in what's called an environment variable. So I can use this program echo, and then I can use this syntax $ variable name to get it to print out the value of a particular environment variable. And here, path by convention is what shells use to store all of the locations on the computer where programs can be stored. Right. So what Bash is doing then, when I give it a command like ls, it's taking this ls name, this ls command, and it's searching through each of these directories in turn until it finds one that contains ls, and then it uses that one to execute. Okay, so environment variable called path by convention is what stores the locations that the shell searches through to actually execute programs. And so you can actually see, well, where is the program that it's loading, and where does it think it's located, using the which the which program, right? So which is a program on your computer that will tell you when you give a command to the shell, where is it actually finding it? So if I do something like which ls, the ls program is actually located here in this physical directory. Like I could, this won't make any sense, but I could like go in, and that's actually a program that is stored on the computer. Like I can use the file commands to get information about it, right? It's a 64 bits object, right? That was like put together by a compiler, that type of thing. So somebody actually like wrote source code for this and built it, and it is located physically on my computer under this directory user bin ls. Right? So that's which. I can retrieve that. I can also do which a. So it turns out there's two versions of ls stored on this computer. -a tells me all of the ones that it can find. And if you notice, going back to path, the way that the shell works is it's going to search through these in the order that they're specified, right? So what's happening is there might be two copies of ls on my computer, but it turns out that it encounters this user bin directory before /bin, right? This is a colon delimited string here. And so it uses this one first because it prioritizes the one that occurs first in the path environment variable, right? So that's environment variables, which, and sort of where programs are located on your computer. The other thing that you can do, or the other thing to keep in mind, is that there's actually a bunch of environment variables. You can ask your shell to print all of them using the env command. Env will just tell you like the name of a environment variable and what it is set to. And there's a bunch of them if you're using standard Ubuntu, but you can see things like, the name of the shell and where the shell is located on your computer. It's bin bash. Let's see here. Like path is in here somewhere. Yeah, path is here. There's just a bunch of other ones, things like the terminal, so the type of things that your terminal can support. So xterm 256 color, that means that I have a terminal that's capable of printing out 256 different colors. That might be useful if I'm, for instance, trying to color code my ls output by having directories in blue and normal files in white. Knowing the shell is checking, well, what type of term, like what's in the term environment variable to decide whether or not certain features are available, right? So a bunch of environment variables available to you. Sometimes they're set up for you by default. And so you might wonder then, well, if that's the case, there's all of these programs that might be stored under the directories that I can find out with which. But if I were to write my own program, so let's say that I write, include, and I have this simple hello world program that I compile here. When I compile it, it produces this a.out file. But you notice that I can't just type a.out like that. It doesn't work for me. I instead have to type ./a.out, and that's what gets it to run. So why is that? Well, again, if we just check our path variable, the trouble is that the a.out file is currently inside of the directory home kleech, right? So home kleech a.out, if I specify the absolute directory of that file, well, I can execute it no problem. The issue is when I just give it to the shell like this, the shell is taking this and trying to search through all of the directories in path. And because home kleech is not inside of my path variable, it won't find it. So it thinks command is not found. And so what I can do if I wanted to get around that, for example, I can modify my path to contain a new string and then everything else after it, right? So remember the format for path is it's a delimited list of directories. So I can say the new path environment variable that I want is home kleech and then all of the other old stuff that was there before, right? So I can do that no problem. I can echo back path and I see home kleech is now in my path variable, and now when I type in a.out, it doesn't complain anymore. Okay, so I can modify environment variables no problem. Now the issue is, if I open up a new terminal window, does that change persist? No. Whenever I set an environment variable, it's only contained within that session for the shell, right? So because I've opened up a new terminal window, it's a new terminal and it launches a new instance of bash inside of that terminal. That doesn't share the same environment that I had before. And so if I wanted that to persist, or if I wanted subsequent new windows to show up potentially with that environment variable, well, then I might have to do something different. And there's two high-level things that I want to get at here, and I'll just messily print them onto the terminal here. I guess one is like local configuration, yeah, and then two is like global configuration, and kind of what are the standards there. So if you if you do ls-la, what this is doing is it's telling it to list all of the files, even the hidden ones, for you to see. And if you actually look in my home directory, there's a bunch of these hidden directories and files that all start with dot. And by convention, a lot of these are just configuration files. Or like local logs that they aren't meant to be human consumable. And among them are two files. There's .profile and -bashrc and .bashrc, and both of these are relevant. So what happens is the .profile file, it says here at the top, this is a little script that is executed by the command interpreter. So it's executed by the shell, like every time a person logs in. So you can sort of add commands that you want into .profile to have it launch all of these things when you log in. And so, for instance, here in this script, what it's doing is it's checking for the existence of a particular directory and modifying path accordingly. So when I log in, this .profile file will launch and it will say, like, well, if the person has created their own bin directory under their home directory, I'm going to add that to the path environment variable. It won't take effect here, but if I were to create a bin directory, I could copy or I could move a.out into bin, and then the next time that I log in, that profile script will run, and then bin will be part of the path, and then I can run things out of that directly. I don't think that'll work if I bring up a new shell because I'm not logging in anew. So if I just echo path again, yeah. So it hasn't picked that up. Instead, what I think does happen, yeah. So bashrc, This is another file that Bash uses for non-login shells. I think that means I could set up things like I could say, and here export means that I set environment variable. I don't think it should make a difference, but I'll export path equals to, let's say, like home kleech and then path again. And I think that, once I make that change, when I bring up a new shell, yeah, it picks up, it launches .bashrc, and it picks up that new directory that I added. All right, so for Bash in particular, in each type of shell will do this differently, but for Bash in particular, .bashrc is a file that gets executed every time a new shell opens. So every time you open a new terminal and launch a new instance of Bash, it's going to read .bashrc. And here I've put in my own things like the editor environment variable. Whenever you use Git, Git checks like, well, what's the editor environment variable? I'll use that for editing commit messages. So I've set that to Vim, and you can do your own thing, whatever you need in your own Bash .bashrc file. Sometimes people will put their own special configuration or commands that they want launched. Sometimes people will have things like, I want my email client to launch immediately or whatever. You could put that type of thing. You could inside of your bashrc file. All right. So that's local configuration. Remember, the other thing that I can do is potentially global configuration. And here, this is again, just sort of convention, or if you've never thought about Linux too much, turns out that there's this etc directory. Etc is this huge directory that contains system-wide configuration for everything. And so if you're ever wondering, where does the default Bash configuration come from? Or if I install a new program, where is its configuration stored by default? And a lot of that stuff is shown under etc. So if I wanted to, for instance, I think, let's see. There's just a whole bunch of different configuration files. All right, so yeah, there it is. The one I was looking for, profiles. There's a whole bunch of configurations that you can use or that are relevant here. So if I have something like, Apache, so a web server, I have the configuration stored in here somewhere. If I wanted to configure the system-wide Vim, that's under etc. So Vim is a system-wide program. I could have my own configuration locally, but I could also set what the system-wide configuration is for all users. And all that stuff is located under etc. And so if you ever wonder, well, where does it come up with the default stuff? It's usually stored under etc. And so, there's a system-wide profile that's shared by everybody. This file gets executed regardless of who you are, and then you can overwrite it with your own configuration if you want to. And so it sets up, this PS1 environment variable, and it loads in, other system-wide configuration, that type of thing. So if you're unfamiliar with Linux setups, again, the sort of computer-wide or system-wide stuff is usually stored under /etc. All right. So that's local and global configuration, and the ability to use, again, I'm still in, the ability to use environment variables and how to set things in your dot profile when you log in, that type of thing. All right. Cool. So how do we use all of this then? Well, I said at the beginning of this, remember, I'll bring up this file again. I want to write some cool scripts to do some cool stuff. And in particular, we're going to use this motivation of being able to download YouTube videos off of the internet. That seems like an interesting use case. So let's say that I care about being able to download a bunch of YouTube videos, and I want to maybe save them or play them later, or do something else with them. Who knows? And so it turns out that there's actually a program for that called YouTube DL. YouTube downloader will, you give it a YouTube URL and it will download the file for you. It will download the video onto your computer and you can watch it later. And there's some amount of limitation to this, like if you do this too much, YouTube will block you or make your download slow. But it mostly works correctly. And so I want to point out something here, which is the use of package managers for modern Linux distributions. So in Ubuntu, there's this thing called apt, for aptitude. It's something called a package manager. So it used to be the case, like way back in the day, you would have to download and install things like yourself. You would have to like download a tarball or a zip file and then build the source code and then sort of like run it yourself or get it to work yourself. And that ends up being sort of tedious, especially for most users and most developers. You might only care about building a special program from source, or maybe you want to check out a repository and build it from source. But you don't want to have to think too hard about dependencies or other features that should just be a part of the computer or that are already mature enough, right? And so the solution to this was package managers, and these are tools that help identify or cluster together different programs and libraries and pieces of code that all sort of work together, and they package them together in like convenience to download like steps. And so there's a whole bunch of things that you can download on apt. Indeed, if I wanted to, for example, download an alternate shell like fish, I could do sudo apt install fish. If I wanted to, or in this case, I want to download this program that downloads YouTube videos for me. Well, all I need to do is sudo apt install YouTube DL, and assuming I'm an administrator, no problem. It knows where to download it. The package manager is smart. It knows where to download the program from. It knows where to put it on my computer, and it sort of removes a lot of doubt from my mind. And now I just have access to this new program that I downloaded from my package manager. Again, in the olden days, you'd have to like go to youtubedl.com and download the source code, build it yourself, and then install it in the correct place yourself. And that ends up being sort of complicated, especially in the modern era where we have hundreds of competing programs and all of that good stuff. So that's apt or aptitude on Ubuntu. If you're on something like CentOS or Red Hat, then you'll see something like Yum. I think Slackware has its own kind of hack version of this. But package managers are usually pretty cool. They're kind of like an app store like that you might see on your phone. So it adds a lot of convenience there. If you're ever curious about what type of stuff is available, then you can use like apt cache to search for various features. So maybe I want to know like, well, what packages relate to Vim, right? So if I care about using Vim as my text editor, I can see all of these different packages that might do something helpful for my Vim setup. So not just Vim itself, but I also have saw one down at the bottom here, like Vim Python Jedi. That's a good one. So Vim Python Jedi, it's a plugin for Vim that you can download through Aptitude that lets you do Python development inside of Vim. So it does like auto completion and linting for Vim. So that's that's an example of something that you could search for and then install later using a package manager. All right. So we've now just used a package manager to install a new program, YouTube DL. That's great. Now we have this ability to download a YouTube file, and maybe maybe I want to go on YouTube, and maybe I want to download some random jams that I could listen to later, and so I'll pick out speaking of fish, we'll download some random C-pop. How about Fishliong Silk Road? I mean, that's a classic keeper, right? All right, so I found it on the internet. I have the URL, Now what I can do then is I can pass it into YouTube DL. I can give that as a parameter, and lo and behold, it will just download for me, and it shows up in my home directory. And then I can open up my file manager, Nautilus, and then if I want to watch it, I can just watch it locally on my computer. Sounds awesome. All right. Well, that's cool. Well, what are we going to? What can we do with it next? So let's say that maybe I don't want to, maybe I don't just want to download the video or whatever, but maybe I care a lot about being able to download just the audio so I can listen to it. I don't want to watch the video. I want to have the music so that I could put it on my Zune device before it bricks. So what I can do is, first of all, I cannot type Chinese characters here, so I'll have to make this easier by just deleting this for right now. So let's say that I wanted to just download audio only. Well, how would I do that? It seems by default YouTube DL only does like video, right? So what I can do then is I can check out what's called the man page. So if I type man YouTube DL, it's going to bring up this interesting description of what the program does. So this is called a man page or a manual. Like a lot of programs that are well supported end up coming with a man page. So when you install it, you can see how it works and what all of the different arguments are to do the things that you care about. All right, and indeed, like man pages are available for all programs, including man. So if I do man, I can see how do I use the man program to view man pages, all of the other programs that might be on my system. I can do things like man kill, and I can sort of see, well, how do I use the kill program to send signals to various programs, right? But we're under YouTube DL because we want to see, is it possible to just get audio? And I can look through all of the different command line arguments that get passed, and I might see something for the program that I care about that lets me do the thing that I want. And in particular with YouTube DL, I might come across the format parameter. Let's say format. This allows me to specify the type of format that I get when I download through YouTube DL. And right here it says, -F or -format, video format code, see the format selection for all of the info. And so I can search, using the /format selection because I want to find that where that is in the man page. And when I come down here, I see a description. By default, YouTube DL tries to download the best available quality, blah, blah, blah. It'll guess for you by default. But there might be other things that you want. So for example, if I want the audio only, I might just say -F best audio, and that will download for me the audio only format that sounds the best based on what's available from YouTube, right? So if you've ever seen, for instance, like on YouTube, you can specify the video quality. One of the reasons that they do that is to save bandwidth or to make the video buffer less depending on connectivity. And the way that's implemented is YouTube basically makes a copy of every video and sort of converts it to a different quality level, and all of them are available for the clients to download. And in our case, we're using YouTube DL for this situation just to download the best audio. So let's try that. Let's try to do the same command again. YouTube DL, we're going to download some Fish Liang, and I'm going to say -F best audio. And well, the other thing before I go crazy with trying to delete this Chinese symbol, let me also see if there's an output parameter somewhere. Yeah, right. All right. So there's a -O on that -O template, so it'll tell me, like I can specify where to store the resulting file. And so rather than sort of letting it download to this Chinese symbol that I can't work without, like on my current keyboard, I will just delete that file here real quick. So I'll delete that, move to trash here. And what I'll instead do is I'll do YouTube DL I'll specify the best audio again, but then I'll also say like test.webm. It'll hopefully download things as this webm file, no problem. Notice, by the way, the file is much smaller now because I don't have any video data. Before, it was downloading, looked like 13 megabytes for the whole video. So it's much smaller now. But if I bring up this same folder again, well, now I see I can open the file, and I only see, or I only hear the music. I don't see anything to go with it. So it's gotten just the audio for us. That sounds great. Great. So what are we going to do with it next? Well, maybe I don't want to open Nautilus every time and have to listen to it that way. Maybe I want to play the file in the terminal so that I can listen to music and a boss standing over my shoulder will still think that I'm working on the terminal. And it turns out, there's actually a program for that you can download. I think it's called MKV, or is it MPV? Yeah, MPV. All right. So MPV, I have to. So I'll download the audio file again. It stores it here, and I can just say test.webm. And look at it. Nicely plays in the terminal for me, and I can just quit like normal with Control-C. Cool. All right. So now I have the ability to both download YouTube videos and play them in the terminal, so that I can, subvert my boss while he's looking over my shoulder or whatever. Don't do that at home. But the next thing that I might want to do then is, well, I don't want to go through the trouble of having to specify download YouTube DL and all of this complicated crap on the command line. Maybe I just want to have a random program that I write that takes in a single YouTube URL as an input, and it just starts playing the file for me on the command line. All right. So here's where we're going to start getting into scripting. So one nice thing that Bash and all of the shells support is the ability to write scripts for them, so you can automate a lot of tedious tasks, right? And so we can go through a couple of sort of interesting cases, but scripting is one of the most powerful things that you can do in a shell, and you can end up, if you learn enough Bash, you can automate a whole bunch of tasks that would otherwise be super tedious to do. And so I want to start, just taking a transition for a moment from this YouTube-based example. I want to show you a couple of things that you can do with scripts. Let's see here. So the first thing that I can do, the first thing that I want to show you is, let's say, variable assignments. So much in the same way that I can set environment variables and they're accessible to me within shell scripts, I can also just sort of like set variables to whatever I want, and then sort of reference them later. I can set a variable and then reference that variable later by prefixing the variable with a $sign. All right, so I can definitely do that. Notice, by the way, the semicolon allows me to put sequences of commands together in sequence. So I can, if I wanted to work on a single line, I can just separate all of the commands by semicolons, no problem. It represents the end of a specific command. So I can set variables this way. And then the next thing that I can do then is looping, right? So maybe I want to do some type of iterative operation, and so let's say that I wanted to, I can go like let's say that I wanted to print out all of the programs that are installed under user bin. I can do it this way, but maybe that's this is big and human readable, and there's too much colors and all this other stuff. Maybe I just want to say one by one, what are all of the programs that I have on my computer under user bin? And what I can do is I can try to do a for loop. So I can say like, well, for I in ls user bin, I can do echo I and then done. And here what I'm doing is I'm creating a for loop, so I'm iterating over this set of strings, and then for each one, I do echo I, referring back to the variable that I just created. And so that'll work no problem. I'm just printing them one by one. It's not formatted in any way by ls. I can just do that, right? And that sounds like contrived. You could also do the same thing with enough ls parameters, but that's another story. The trick, there's a couple things to take note here. The first is, the backtick operator. The backtick allows you to embed the output of a shell command within another shell command. So for example, I might want to have a variable called username that contains my username in general, right? And so I can definitely say like, well, kleach, no problem. And I can echo, if I could even spell my name correctly, would help. Username, wow, username kleach, echo username. It's a long day. So I can definitely do that, but if I want to give somebody a script in general, then I might not know what their username is ahead of time. And so instead, I might take advantage of the whoami command that reports what's the current username. So I could instead say something like username equals whoami, and when I echo username again, it reports kleach again. And so that's what I was doing up here with this command, with this for loop. I have the backtick operator, and what I'm doing is I'm taking the output of ls user bin, and I'm treating that as a big array of strings. And Bash does that sort of implicitly. So for each string element, so for each program name listed under ls user bin, I can iterate through those, and then I can just echo out the name, right? Sounds neat. And so I could do some more advanced things, like if I wanted to copy all of the files from one directory to another, I could do like cpi to cp. In fact, that actually sounds fun. So let's create a garbage directory. So copy bin. So I'm going to say for I in ls user bin, I'm going to do copy I to home kleach copy bin I copy, right? And what's going to happen is it's going to copy the original file into this directory, and it's going to append all of them with this dash copy. So let's I see. So when I specify copy, I have to give the whole directory. Why is that, by the way? So let's just go back to here for a moment. The reason that failed was because when I print out everything, that I'm not including the user bin part, and so I need to copy from user bin I to that new directory, and maybe it will take not that long. All right, so if I go under copy bin, now I have a copy all of these silly programs. Excellent. Yeah, and I can have access to them if I wanted to. Incidentally, I can also do du to sort of see how big a directory is. So if I wanted to know, like, oh, okay, I have 500 megabytes worth of programs on my computer. Awesome. All right, so that's some basic scripting. What we can also do, though, is we can put things inside of a file that we can execute later. And so I can put some of this scripting knowledge to work and save it in a file, and then execute the file later whenever I need it. So the way that scripting works then when you're storing things in files is that by convention, and this is totally arbitrary, what you do on the very first line is you specify what's called the interpreter. What is the thing that is supposed to be executing the code that's contained in this script file? And that's, again, by convention, you start with a shebang, with a hashtag and an exclamation mark, and you say, usually bin bash or whatever interpreter or whatever shell you want to use. You can do a whole bunch of things this way, like you could put bin Python at the top and have it contain Python code, and it'll work just fine. But for our purposes, we're talking about bash scripting, and so I could write mostly the same thing. I could say, well, for I in ls user bin, I want to do echo I, and then I'm done. Right? And again, I can't do it this way because it's not my I can do it that way currently because in my path I have HomeKLeech. Currently it says permission denied though, and the reason is it goes into permissions. I currently, so Linux works on a 3-bit model. You can either read something, you can write something, or you can execute it, or you can do any combination of those three. Currently, and by default, files are not executable. That sounds very dangerous to let people execute arbitrary code unless they know about it. So by default, the only thing I can do is read and write this file. And instead, I can use chmod. I can change the permissions. There's a man page on chmod, so I can change the file mode to include execution. So I can chmod and I can say the user gets to execute test.sh. And so now when I check test.sh again, I can see the X bit has been set. And so now I should be able to execute it. And much like we saw before, no problem, sort of implementing the same script. All right, so I can put whatever bash commands I want inside of a file like this, no problem. And there's a bunch of advanced things that you can do to let you sort of make decisions, right? So in addition to for loops, there's also if, and you can say something like, well, let me just let me make this output slightly shorter. So let's just make it list all of the things under my home directory. Well, let's test that first so we can just sort of verify that it's working. So test.sh, listing out all of the files in the current directory. But maybe we want to do something more interesting. So I could say like, well, if, and then in bash you have this open square bracket. I could say, if I equals test.c, then I'm going to echo I, going to echo I, this is my most dank file. Right, and that will be that. And then I can do, else. I'll just echo it like normal. And then following bash syntax, fi to close an if. And that sounds, I think that's mostly correct. Let's try it out. Sure. And here now it's iterating through all the files, and it notices, well, if the file name is test.c, it sort of says, well, this is my most dank file, just like the script said it could. Right? So you can do all sorts of cool, tricky things with bash. One thing, you can also do simple arithmetic. Like you can set values to integers. We can do that now, actually. So I can say I equals 0. No, let's not use I. Count equals 0. And let's say count equals, and the count plus 1. There's a weird format to including, to doing arithmetic in bash. Let's see if I can remember it off the top of my head. Apparently not. So I can do, I feel like there's $2 signs that have to go into it, and then you have, right, let us try, no, that can't be it. This, count plus 1. And then I can, at the end, echo out count. You have count files. So you can see that I clearly didn't do it correctly. So ordinarily bash operates on strings. So what's actually happening is it is not I think it's like count plus, like there's some weird syntax. I might have to Google it real quick, so I don't remember it. I never use it, so 800. Yeah, there we go. Wow, got to it in the end. All right. So again, like by default, variables are treated as strings, just sort of regardless of whether you have quotes or whatever. Because again, Bash is like mostly concerned with interacting with the operating system, and so a lot of the time you're passing like standard character streams back and forth between programs, and the notion of like integers and arithmetic is sort of more complicated to access. And so if you need to, you can. Although the syntax is weird, $, double parentheses, and then you put in the math expression you want to do the arithmetic for you. So Bash can do all sorts of crazy things for you. It's an interesting program, and it's a powerful scripting language. So you can definitely take advantage of it. Now returning to where we were earlier. Remember, our goal here was like, well, we want this script that allows us to download a video off of YouTube and then play it in the terminal sort of all at once so that we don't have to think too hard about it. So we can go into our test.sh script, and let's just get rid of all this stuff. And what we are going to do is we're going to just roll our own script to package these two pieces together. So we're going to say, YouTube DL, and we're going to ask for a command line argument. Command line arguments, they're passed in order. Why don't we just say like video URL is 1, and that's $1 represents the first argument passed on the command line. $0 refers to the name of the script. It sort of follows the same convention as argv that you might see in C. So I'm going to have a script that takes one command line parameter that specifies the video URL, and then I'm going to pass that to YouTube DL. And recall earlier, I want to say I only want to get the audio, so I'm going to say f best audio, and I'm going to output it somewhere. I'm going to put it in the temp directory, myfile.webm. Sounds great. And then next what I'm going to do is I'm going to just pass that into MPV. I'm going to say, well, I'm going to play that, and that sounds wonderful. I'm going to pass that right into MPV so that I can listen to it on the command line, right? So what's going to happen is, the script's going to run, YouTube DL is going to pick up the parameter from the command line, and then it's going to store it somewhere in a temporary directory, and then I'm going to use MPV to play it directly. All right. So let's see if this possibly works. Test.sh, and here I'm going to paste in my same YouTube URL. And look, it works, right? So simple combination of programs in a script that I've written. And now I have my own thing that lets me watch YouTube or listen to YouTube videos. Okay. Awesome. So what next? Well, maybe I want to be able to listen to YouTube videos, and I want to be able to browse for them and find YouTube URLs without having to open Firefox. Maybe, again, because I'm trying to escape the wrath of my boss who's looking over my shoulder, maybe I want a browser that I can use to navigate YouTube in my terminal so it still looks like I'm doing something technical and complicated. So it sounds like what we need is a text-based terminal. And so what we'll do is we're going to look for the perfect candidate for this called Elinks. Elinks is a text-based terminal browser that runs in your terminal. So there's no graphical elements to it. It's not like Firefox or Chrome or whatever. It runs inside of your terminal. And so I'll show you what it looks like in a moment. But what we're going to do is we're going to build this from source. And so if you go on the website, you can find a download. I just got the most recent version. I've already downloaded it to sort of get started here. So over here, I have the source code package here, and I'll just untar it. So I'll untar Elinks, and it dumps everything into this directory. And here we're going to get into build systems. So again, by convention, big software projects just will ordinarily contain some type of, or use some type of build automation to make the job of compiling easier. When you have hundreds of source code files, when you have many different platforms or systems or components working together, there's no way in hell that a standard run of GCC is going to cut it. Instead, people invest a lot of time in making or using build systems so that whenever a new person tries to compile from scratch, the build system will sort of make sure all of the requirements are in place, all of the file names are right, like all of the right parameters are passed to the compiler, and so the build system is going to do that for us. And there's a bunch of different ones. You've already seen Maven, which is used for Java, and in this course already you've seen Automake, or the use of a configure script. And so it's project specific. Usually they'll include it in the README when you go to download a new project. But whenever I download a new project, I'll sort of ls and I'll look around for hints of some type of auto build system. And you'll get used to this over time. One of the most common ones is the configure script, where this script will set up the compilation. So what the configure script, you run it, and the idea is that based on the features that you want compiled and based on the environment that you're compiling for, it's going to generate a makefile for you that you can then run to have it compile successfully. And so, this is a very common pattern in a lot of C-based projects to use a configure script. There's also things like CMake or scons that have, varying levels of complexity that might make more sense for some projects. But for now, we'll just take a look at configure because it tends to be super common. So I might want to run this configure script, and ordinarily you can run --help to sort of figure out what's going on with this specific project. So here in Elinks, immediately it dumps out a bunch of stuff. And with configure scripts, there's a bunch of different things that you can tune and that you can look for. For example, when you build and compile from source, you can use the configure script to specify where you want the program to be installed later. So, for example, by default, I might say that I want all of my programs to go under user bin. And so I might say, --bin-dir equals user bin. And so eventually, once I compile the program, it knows to install the compiled version into that directory. But maybe if you're not root, for example, if you're not the administrator, you could specify here on the command line bin-dir equals, home kleech something, and it'll know to compile there and build everything there rather than in your system directory. And so that's how. So you can use this to, build on systems where you're not the administrator. There's also more project-specific things. So for Elinks in particular, for example, you can tell it to compile support for 256 color terminals. I might do that, since my terminal supports it. And I might have things like CSS. That sounds important for colors and formatting. And maybe I want to have like OpenSSL. Maybe I want to be able to connect to encrypted websites. That's something that you can decide to compile for Elinks. All right, so we're going to try it. So I'm going to say I want to configure, and I want to say I want to enable 256 colors. By the way, tab completion works in Bash usually for this type of thing. And I also want to say with OpenSSL. Sure. Let's see what happens. Configure, what it's doing is it's going to run through a bunch of checks. It's going to see what version of the compiler is it, what type of program does the compiler produce? Is it x86? Is it ARM? Is it MIPS? Is it able to distinguish between 64-bit doubles and 32-bit floats. All of that type of crap is checked at once with the configure script, and once it's finished, it kind of gives you a summary of what things are in there. So it's telling me like, okay, it has SSL support using this OpenSSL library. Wow, it's got support for bookmarks. Bookmarks, how decadent. It has support for 256 colors. Awesome. How amazing. And in particular, what it'll end up creating is this make file, so that now I can make, and it'll end up building. By the way, if you've never realized, you can use the -j parameter to specify how many threads to run in parallel for make. Because I don't want to crash the video thing, I'll actually just do J2 rather than J8, and hopefully things won't break on this recording. And then, what make is doing is it's running a sequence of compiler steps, GCC whatever, and you can see what it's doing step by step here. You can see like Elinks isn't really great. It's an old project that isn't used to. I think I have GCC 9 on this computer, so it's giving me all those garbage warnings. If it were a better supported or better tested product, like they might add in like checks, like, oh, let's make sure the source code can be compiled without warnings on GCC 9. But since they haven't done that, it's compiling with a lot of warnings. No errors yet, though. That's good. And so I'll just give it a minute to cook. J2 instead of J8. Clearly a bad choice. All right. Cool. All right, and it seems to have compiled successfully without any issue. And in particular, it links it, so it outputs the binary by default into source Elinks, which I'll go to in a moment. But in principle, there's nothing that prevents me from running make install, where it would copy that final binary into user bin. I won't do that for now since I don't really need it. So before I move into that, though, there's also another thing to point out. So when you run the configure script, ordinarily it'll create this file called config.log. You can take a look and say like, okay, here's the command that I ran to ask for various platforms. Here's a bunch of crap about the system that I'm running. Let's see here. Let's go down to C flags. All right, so you've seen this already in. Go back here. You've seen this already for libpng. You can use the configure script to also set these environment variables, C flags and CC, to change which compiler is being used part of your build process. So for instance, in homework 2, you will use AFL, which requires a special version of GCC to compile your program so that you can fuzz it. And so you'll use a version called AFL GCC rather than normal GCC. And so you'll set that using the CC environment variable. Again, that's by convention. Similarly, C flags, that's the parameters that are passed to the compiler. So in this case, I'm using -G to put debugging information, O2 for optimization, WAL to warn about everything, and then there's some other things about like executing the program. So you can set those environment variables during configuration to affect how the program gets compiled with make later. Awesome. So we've run make, it's already compiled, and indeed we see this nice binary here that we can run on the command line. That sounds awesome. And indeed, when I open it up, it gives me this fabulous black and white text environment browser where I can, enter in things and have it search, and I, operate much like like a browser, except it's text-based. All right, so where are we going with this? Let's say that I wanted to go to youtube.com and let it load for a bit, and maybe I want to use this. Can't seem to highlight it. There we go. This text box, and I want to again, I want to search for fish Leon. Can't get enough of that CPOP, and so I want, and then I find a bunch of candidate videos. And eventually, the way that it's organized is bad, but I can come down to these listings, and again, I can sort of highlight these various videos and sort of like watch each of them in turn. Here's the trick, though. When I click on a link, doesn't, I don't like the message, right? It doesn't work. We'll stop supporting this browser soon. I'm sure they've already stopped supporting it. All right, so I can't actually play through Elinks, but I am desperate for being able to, listen to all that CPOP on the terminal without my boss knowing that I'm surfing the web for YouTube videos. So what can I do? Maybe in so what I can do is I can look through all of the configuration for Elinks. Now this is going to be project specific or whatever. It's a type of like effort that you need to give when you're trying to solve these sorts of system programming problems. One of the things that Elinks supports is the ability to do what's called URI passing. So you can bind a special key so that when you press that key, Elinks passes the URL that you're currently viewing to some script of your choosing, and that's called URI passing. So that sounds great. Right now, I have, maybe what I want to do is I want to pass the URI of the link that I'm currently highlighting so that I can send it off to this script that I know downloads and plays YouTube audio in the terminal for me, right? So I can do test.sh and have it do this, and it'll bring it up for me. And in particular, I've already added test.h into my path, right? So sounds like all I need to do then in Elinks would be to do a couple things. First, I want to go back. I want to, it doesn't matter for now. I want to bring up my options again. I want to go under this configuration document. I want to go into URI passing, and I want to add one. URI passing. Add. I want to do like YouTube DL. So we'll just call it that, and we're going to say, first of all, let's delete it. I want to add, let me spell it correctly this time, YouTube DL. Awesome. I want to edit it, and and the value here is whatever command I want to run. So test.sh, and I want to take note of this format here. %C means that it'll pass along the current URL. Means the current URL. Yes, that's right. So I want to do %C. I think that is all that I need, and I will save that. By the way, notice it saves it under a .prefix directory in my home directory. And now the question is, well, how do I link this up? I need to be able to cause this URI passing to work. It wouldn't be under that. Browsing. Basically, what I need to look for now is a way to bind keys into doing URI passing. Let's see, user interface. SAS bar, no, that's not right. And I might have to Google this because I don't remember off the top of my head where to get the bindings on Elinks. I may have to edit a configuration file directly. It's not good. Memory options, display. Do new tabs. No, that's fine. Downloading, scrolling links. No. I would have thought it would be under here. Option manager. I feel like there might be some other. All right. So what we'll do is we will go out of Elinks and we'll go into this Elinks directory and we'll try to do binds. So I'll look for URI passing and I'll say like, well, I want to do. Yeah. So in fact, it's saving the URI passing thing that I've already had here. So the YouTube DL URI passing thing just uses this script. So it'll pass in that URL, you see it. Now I need to say, like, how do I do bindings? Supposed to use the graphical views here, no support for these action submenus available, like binding keys, submenus. Use the terminal command. Submenus are also available in keys. Yeah, but how do I bind? Right, so here I probably just have to open up Elinks bind key. Bind key map keystroke action. All right. Oh, link external command. Command. Yeah, that might be what we want. This would be bind main. All right, so let's try that. So we'll put this in our elinks config file. Shrink this terminal here. And let's try to do just a binding at the top. Automatically saved options, that's fine. Bind main, and let's say I want to say, well, let's say like F11 equals link external command. If that's what it was called. That's link pass URI of current link to external command. That sounds fine. Let's make sure that I'm using that correctly. Stack Overflow, source of infinite wisdom, but not for this answer. Passing YouTube link through external player. Well, that's convenient. Sounds cool. Where's the binding for it? This will be the same thing. Let's go back here though, see what this is. Receiving link, passing YouTube, that's fine. Sure, but it's not, yeah, I need the binding thing though. Binding URL handlers, that's fine. Why it's not. You can see, no one likes to write documentation. So we're having this issue. That's not good. Main mapping. Right, yeah, so let's, that actually may be more useful. So I can't, all right, anywhere else? All right, so let's try it this way. We'll go back here. Downloads, Elinks, source, Elinks. I want to say so. We'll go to setup, and then that's right, key bindings manager. I see. Let me full screen this again. Ask the URL, URI of the current link. Kernel command. Let's execute this. We're going to say F12 is the keystroke. Is that want? Right. All right. Well, we can try it anyway and sort of see what happens. So for one of these, let's see. When the sky has his life changed forever, sure, let's press F12. All right, well, wait a second, that doesn't sound right. Oops, what happened? Feelings. It started playing something, but I don't know why. We're almost there. Elinks. Doing that, but why? Test.sh slash, I mean, %C should be the current URL. I know what the issue is. Okay. The issue is under test.sh, we output to that, we output to like temp my file, but then we never remove it. And so it may be something different going on. Yeah, so that should be good. So it takes out my video URL, puts it into that file, and then I play it in MPV. Should almost be there. Let me remove it for good measure. Elinks, youtube.com. And, come on. F12. Okay, excellent. All right, so it seems to be working now, right? That video, I assume that was the sound of whatever thing that was. So the next thing that I need to do then is to not make it interrupt the workflow that I'm seeing in the terminal, right? So the Elinks was disturbed by the outputs of this random script executing, and that doesn't look too good. So the last thing that I want to do then is to modify this so that it actually opens up a new terminal window so that it's different from whatever Elinks is doing. Like it's a different terminal window from whatever Elinks is doing. So how do I actually do that? Well, it turns out that there's a thing that you can launch called GNOME Terminal that opens up an entirely new window for you. And if you look at the man page of GNOME Terminal, you can pass it a command with dash E, dash E or dash X. Yeah, that should be fine. I see. Okay, so what we want to do then is we want to make sure that this test.sh script gets run in a new terminal. And so I will have something like GNOME terminal test.sh blah, and it opens up the wrong thing. Let's see, that's not. Oh, I didn't. Yeah, okay, of course. So we'll do dash X. Downloads it and puts it into that thing, and then I can close it, no problem. Everyone's happy. So I think, I guess I can actually just do it this way. Nothing stops me from doing GNOME terminal X. Let's see if that just does it. Downloads Elinks, source Elinks. I'll just go to youtube.com. Keep doing that. Maybe, rather than Bishliong, maybe I want some other random cpop, and instead, when I scroll down here, do this. Yeah, so like if I just want to play this, I think if I just hit F12 here, opens up a new thing, and it starts playing music. And so now, I can just return to Elinks as normal. All right, so that's building and compiling Elinks and also configuring it, and by the way, sort of rehashing from scratch various configuration files that I didn't realize I forgot. But now you too can, use Elinks to escape the watchful eye of whatever boss or parent or whatever might be looking over your shoulder, so that you can just listen to YouTube all day and everyone thinks you're doing nice technical work.